Doo-doo-doo. So I think we are live. Yes. Amazing. Amazing. Hello, hello, hello. Good morning, everyone. How are you all doing on this Sunday? So let's wait for some people to join in and then we will start. So today, as the thumbnail suggests, we are going to solve the advent of code, the first problem of advent of code that I was just wondering what should I came like up with the live stream. So let's try to solve this. Just wait for a few people to join in. All right. Okay. I think we should close this window for now. Cool. All right. For now, let me just post in my window. So this is for GitHub. This is for X. Do 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 do. So if you join this live today, make sure you show your presence by saying hi on the chat. And then we can start. And this link is so that you can buy me a coffee or pizza, whatever. Amazing. So let's wait for a few people to join in. Till then, let me just open the problem that we will solve today. Cool. Advent of code. So, ooh la la. So this is the problem. If you can see, let me just keep the browser like this. So guys, show your presence by coming on the chat. And make sure you like this stream. And then we can start. And also please tell me if the audio video is going fine. Are you able to hear me or see the screen? All right, so day one. I know it's very late to solve the advent of code 2025, but the problems are never old. And how you tackle the problem is never going to be old. So we'll tackle this together. So this is our problem and some fancy stuff over here that, hey, you are on the North Pole and so let's understand this thing. So the actual problem is over here and we have a sample input over here, and this is a example case that they have showed with the proper output what has to become. So now we only have to just deal with the program that we have to write. So we are choosing Rust to write this because we are learning Rust, so we'll do that. Amazing, we have one like. Cool. So feel free to come on chat, all right, and let me know how your day going. And if you're a techie, let me know what are you working on, your project, your side project, and just tell me in the comment so that we can start. Till then I'm just like going through this. All right, so the day one problem is secret entrance. The elves has a good news and a bad news. Okay, good news first. The good news is that they have discovered project management. uh, this has given them tool they need to prevent their usual Christmas emergency. For example, they now know that the North Pole decorations need to be finished soon so that other critical tasks can start on time. Fair enough. The bad news is that they have realized that they have a different emergency. Cool. Now the problem statement is this. According to their resource planning, none of them have any time left to decorate the North Pole. Okay. Now, to save Christmas, the elves need you to finish decorating the North Pole. Amazing. So, the elves need us to do the decorating. Well, we can do that only if we can get to the North Pole. Collect stars by solving puzzle. Okay, okay, that is good. So, each puzzle we solve will get one star. All right. Now, we have arrived at the secret entrance. So, somehow we just reached to the North Pole. Now, we are ready to start decorating. That's what the document says. Now here is the turn. Unfortunately, the password seems to have been changed. Oh my god. The password seems to have changed. Can you see the password word like very bright? So the problem revolves around this thing. The password seems to have changed. So you can't get in. Amazing. Now the document taped to the wall helpfully explains. So uh which CMD for use? Damn man. What you just wrote. We are just solving one problem, not another. Which CMD for use? Okay, try to be more specific, my friend. A document taped to the wall helpfully explain. Now here is the contradiction. Do software engineers really read the document? If not, this we have to read, unfortunately. Okay, so the document we have to read. Now, due to new security protocols, the password is logged in the safe below. Cool. Please see the attached document for the new combination. Okay. Now, so the condition here is we have arrived to the North Pole. So we have our decorating stuff with us, bells, lights and all. But the door is locked and the password has been changed. The documentation is there. All right. So the password has been changed. So it turns out that we have to figure out the password. Okay. Now here's the thing. Now use your imagination. So before that, I can see we have only one like and five viewers that are watching this. So guys, make sure you show your support, like this stream, share, and bring out all your dev friends so that we can solve this together. All right, I need you on this. Amazing. Okay, so now use your imagination. All right, so the safe has a dial with only an arrow on it. I hope you understand this thing. So we have a kind of safe that has a circular dial that has an arrow or a pointer. All right, so let's see this thing. Okay, so this is kind of, this is a dial. All right, and we have a pointer over here like this. I think so, this is it, right? uh, so this could be a dial. and we have a pointer over here, right? This could be the pointer, let's say. All right, so this is our lock looks like. I hope you can see it. Let me just adjust this thing over here. How can I just say, I'll keep it over here. Cool. Okay, so this is our dial, so we have to do something with it. Okay, the safe has a dial with only an arrow on it. Around the dial there are numbers 0 through 99 in order, so they are not scattered all like, so they don't have any randomness, right? So it says the number are from 0 to 99 and they are in order, either increasing or decreasing. So we can like imagine that they are spread around this circle. Okay, you must have seen this thing in movies or something like that, right? So we have a circle and we just rotate it, you know, to in order to enter the password or the number combination. As you turn the dial, it make small click noises. So we do this, if we rotate the dial, it like make the noise like click 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 click, right, as it reaches another number. So it turns out that there could be numbers around here. So there could be numbers around here, 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 like this. They should be scattered all over places. And as we move this pointer toward any direction, like this or this, it makes a clicking sound. Okay. The attached document. Now the document, your puzzle input, contains a sequence of rotations. One per line. All right. So we have a documentation like this over here. Like this. And we have some rotation over here, one per line. Like this. All right, so this is the documentation and these are the line by line instruction or rotation that we have to perform. Cool. The rotation start with an L or R, which indicates whether the rotation should be to the left towards lower number or to the right towards higher number. So let's say this is our left and this is our right. So it says where is it? Okay, L and R, and the rotation starts with L or R, which indicates whether the rotation should be to the left towards lower number. Okay, this is R and this is L. Right, so towards L we have lower number, so it could be a negative, negative, not negative, it could be a descending number over here, and over here on the R there should be a greater number than the center, right? So it means on the center we will have a median value, and towards its left we have a number that could be decreasing, and on the right we could have numbers that are increasing, right? So if there if let's say the pointer is on 20, so on the left hand side it would be 19, 18, 17, and on the right hand side it would be 21, 22, 23, like that. So it, and we already know that the numbers are from 0 to 99, so it could be possible that the pointer is in the median value like 50 or something. Then the rotation has a distance value which indicates how many clicks the dial should be rotated in that value. Okay, so apart from in the instruction, apart from L and R, there is a value as well. So let's say there is a value X which represents the number of clicks. So if it's 2, that means the dial is rotated twice, so it will be click click tick tick, like that. So if the dial were pointing at 11, so it says an example also, if the dial is pointing at 11, right, a rotation of R8 would cause the dial to point at 19. So let's say if this value is 11 and if I do R8, so if I do R8, that means 8 clicks from 11, so it would be 19. Okay, fair enough. After that, the rotation of L19. And after that, if I do L19, L19 means towards the lower number from the 19th value. Now the pointer is at 19, and if I do L19 means it could be on 0. Yes, because okay, yeah. L19 means towards lower number 19 clicks, right? Because the dial is a circle, turning the dial left from 0, one click makes it point at 99. Okay. Similarly, turning the dial right from 99 points at 0. Okay, so it turns out that uh, there could be 99 and there could be 0. The dial is circular, so if it rotates like this from 0 towards this thing, it reaches 99. And from 99s, if we do a rotation, it could reach 0. So the dial is circular. Okay, so if the dial were pointing at 5, the rotation of L10 would cause it to point to 95. Okay, this makes sense. So 5 would be somewhere here. So if the pointer is at 5 and if I do a rotation of L10, if I do a rotation of L10, then the pointer will get shifted towards here. It crosses 0 and reaches to a point of uh, 9 pointing at 99, right? So it causes it to reach at 95 because 5 from uh, because it's at 5, and if I do 10 rotation towards left, so 5 rotations will point it to 0, and another 5 because the dial is circular, so it will reach to 95. Okay, the dial starts by pointing at 50, so it means here is 50, so the dial starts at pointing 50, right? So it's in center kind of thing. You could follow the instruction, but your recent required official North Pole secret entrance security training seminar taught you that the safe is actually a decoy. Hmm. The actual password is the number of times the dial left pointing at 0 after any rotation in the sequence. Now this is something we have to notice how what could be like what the output should be. So it says that that this safe is actually a decoy, but the actual password is the number of times the dial is left pointing at 0. Now see the play of words here, because we are dealing with left and right. So this guy it like this guy just entered the problem statement with left in it, but this left is not direction wise left. It says left pointing at 0 means it when we just rotate the dial, the final output, if the pointer stops at 0, so this says this, if the pointer stops at 0 and we multiply how many times the pointer comes at 0, that would be the answer, right? So this is our example. Now this is the way we will imagine this thing as a circular dial, but programmatically what we can assume that this is a list kind of thing. Let me just show pointer, how we can adjust pointer in this. Can you see it? Okay, I want to adjust the pointer. Stroke width is this. Okay, yeah, so let's understand. So let's say this is our number like safe, so we have number like this, and somewhere at center it is 50, and the pointer is pointing towards 50. Here is the L value, here is the R value, here is the L value. The L value, it should be 0 somewhere here because so it is a lower number. R value should be 99. I hope you can see it. Can you see it? Yes, you can see it now. Cool. All right, we have 2 viewers, 2 likes. Fair enough. So, guys, if you have any questions till now, feel free to come on chat. Let me just start a poll. All right, so the poll is running. So what you can do is opt for the polls. The poll is running. Just do some voting over there. All right. Come on, people. Then we'll start this thing. So did you like get what the problem statement is? So we have a kind of list over here that has number are in order, right? So 0 to 99. The pointer is in starts from 50, and towards left we have a smaller number, and towards right we have bigger number. Let me just do it again. Yeah, rotation should be to the left towards lower number. Okay, towards left we have lower number like this, and towards right we have bigger numbers. Now we have to find the password, but it turns out that it is actually a decoy. The whole purpose to find the password is how many times the pointer stops at 0. Actually stops at 0, not passes, right? It stops at 0, and we will multiply all those times, right? So let's say over the given set of statement over here, so we will have like instructions, right? And on these instructions, so if the pointer actually stops at 0, we will keep track of how many times the pointer stops at 0. Maybe we can just multiply by the times or just find the length kind of thing, right? Okay, so we can have a variable, let's say x, and we will just increment it based on how many times the pointer stops at 0, and then we will just publish the result. So that would be our output, right? So this would be the answer, right? So let's go through this thing. So we will have a set of instruction like L68, L30, L48, L5R. So we will have something like this, right? So based on this thing, we have to deduce its answer. So what we could do, cool, because the dial points at 0, a total number of the total of 3 times during the process, the password is this example is 3. Analyze the rotation in your attached document. What is the actual password to open the door? So this is the problem we have. So the pointer starts at 50, and we get this thing, right? Let me just copy it. Let me just see if I can paste it over here. Okay, so this is our instruction, right? So the first thing is L68. So if I do L68, that means the pointer, I have to shift it towards a lower number 68 times, but after passing 0, it should reach to 99. So we have to figure this thing out, how we can like do this thing, because the pointer starts at 50, and if we are doing 68, definitely it will like cross 0, right? But after crossing the 0, it should not I mean, if you think it like number wise, tide enter no. So if you think it like number wise, let's imagine this thing. Imagine there is a slider, right? Imagine there is a slider. For now, imagine there is a slider. That's why the problem statement says it's a circular, because after like passing 0, it will again reach to 99. It's a circular dial, right? But think it like that way. If the pointer is pointing at 50 and if you are just sliding the pointer towards left toward the lower number 68 times, because 0 to 50 will only, the distance is 50 points, right? But the we have to shift it 68 times, right? So after 0 we have to count it from the 99, so it will reach somewhere over 99, and 50 plus 18, it should reach 99, 18 points from the 99 now, because it's a circular dial, right? So the after dial is rotated, the point is at 82. That is why it's on 82, because it's a circular dial. After passing 0, it will start from 99. Is this does this make sense? Guys, also if you opt for the polls, make sure you put down a comment. What is your preferred tech stack? What are you working on currently? And if you are just visiting, make sure you like this stream. Tide Hunter, I don't speak Marathi, I speak Hindi, I speak English, I speak Kumaoni sometimes. Yeah, so if I rotate the dial 68 points, it reaches to 82. Now after reaching to 82, now the pointer shifts to 82. Understand this thing, keep tracking of point, like keep track of the pointer, right? Now the pointer is at 82, the pointer is at 82 somewhere here. Okay, now the second set of instruction is L30. Now it's again L30, so it means I have to shift it towards a lower number now. So from 82 I have to shift 30, so it becomes 52. Now you can imagine how we are going to do this. Can you think? Let me just shift the chat window up. Let me shift it here for now so that you guys can see it. Cool, we have one vote. So whoever voted down, please let me know your tech stack. 2 votes for now. So can you like think how we can do this? It's all about numbers, right? So if we encounter L, we have to subtract. If we encounter R, we have to add, because towards left we have lower numbers and towards R we have bigger numbers. The only main thing over here, okay, so we can reduce that. Okay, 82 minus 30, we get 52, right? The only thing that is going to be a problem here is how do we do like from 0 to 99, how we switch, what kind of formula or what kind of thing we can figure out, so that if the number passes 0, it goes to 99, the answer goes to 99, right? So like the pointer starts at 50, if we do L68, the pointer goes to 82. So we have to figure out, we have to think how it can be done. It's a simple plus and minus which we can figure out, right? So it turns out that 82 minus 30, 52, and then 48. So it does R48. So it means 52 R48. So we have to shift it towards the bigger number. So we have to figure out these things. Hello, hello. I'm just solving this thing, advent of code, problem 1. Amazing. It was good. Cool. Guys, come on. Feel free to come on chat. All right. and off for the polls. Okay. And make sure you like this stream, and if you find anything wrong about it, if you have any questions, feel free to come on chat. It's Sunday, we can hang out. Come on. And if you are a dev, make sure you tell me your what tech stack are you working on. Come on, I hate the stream. Buddy, come on. Tell me what you just said about this stream. I like the honesty, by the way. Yeah, so we have to figure out this thing. So it's so how we can do that? Let's copy these things as well so that we can have it over here. Now we'll just perform some operations over here, right? These are our set of instructions. This is the example that is saying that okay, it has been rotated to here and here. So as you can see, the pointer stops at 0 over here. So 0 1 times, 0 2 times, 0 3 times. So the answer and the password is 3. So this is what we have to do. This is what we have to figure out. Right. That's still not visible. Yeah, I hope this good. So can you guys like say or like think or like suggest anything that we can do? So it starts at 50. If we shift it towards L, we got 82. Okay, this thing is very important over here. This thing we have to solve. How we get 82? So it turns out that it's a regular plus and minus, right? Because we can see it here, right? L to L is just a simple minus, and R to R is just a simple plus. But the whole issue is over here, that how we can get so if I subtract 50, so it's towards lower number, right? So if I subtract 50 minus 68, we get, what do we get? We get a negative number, right? Right, we get a negative number, some negative x. Now we need this number, so that we need to perform something with it so that it goes to 82, and then we have to create a formula, and that formula would be run for this entire list, and we'll keep track of the zero, how many times the zero. Can you please explain the problem statement? Yes, I did, but again let me just tell you. So we eventually we have to do a decoration on North Pole. It's so we are there on the gate of the North Pole with our decorative items, but as soon as we enter to the gate, we saw a lock, and that lock, we don't know the password. We have to find the password, and there is a documentation there. There is a page there that has a documentation about how to get the password. So the password says, the document says that there is a dial. Imagine it a circular dial. The pointer is and the numbers spread in order, right? So either ascending or descending. The pointer is somewhere pointing in between. So we will have a 50. It will point it towards 50, and towards left we have smaller numbers, right? So we have descending numbers, and towards r we have ascending numbers. So let's imagine, if we go from here, we will subtract from center towards left, and if we go towards right, we'll do a plus. Okay, so this is our thing, and we have a list line by line instruction how do we rotate the dial. All right, and the list goes like this: L68. So the L shows the direction of rotation towards left, and the 68 shows the number of clicks we have to perform on the dial. So the dial, when the dial rotates, it do like click 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 click, click like this, right? So if it's a 68, L68, that means towards left, towards a lower number, we have to shift it 68 times. So the point, so this is an example that we have to that they have given. We need to figure out the password, and it turns out that the password is how many times the pointer on the dial actually stops at 0. So we need to calculate it until we finished with our instructions, right? So we have to perform these instruction line by line, and in between these instruction, if the pointer stops at 0, we need to keep track of that, and later on we will just return the count how many times it actually stops at 0. So if did you get this thing, Pranjal? Any questions? Cool. So yeah, this is what we are doing. So if I do L68, the pointer starts from 50, so it's in between, in like center, so like this, in center. And if I do L68 towards L68, if I do L68 means towards a smaller number. So yeah, one more thing to be like find over here is, as soon as it crosses the 0, it reaches the 99 again, just like in a circular dial. So we need to that information is important. So if I do L68, that means 50 towards 68 clicks towards left, so 50 will do subtract, right? Obviously we'll subtract it 50, like go 49 48 ऐसे करके we will reach at 0, but will not, but this will not be counted because we have 18 more clicks towards 99, right? Because 0 to 50 is the distance of 50, and it's a L68, so we will do 68 minus 15, we reach 18 more. So it will reach somewhere like this, 82 or somewhere, whatever the answer is, 82. Yeah, it will reach at 82. So we have to figure out this thing, and we have to come up with a general formula or a kind of program that if we run these instructions, we get the answer. So this is the thing that we have to calculate, how we get the 82. Yeah. So if I do 50 minus 68, if I encounter L, I'll have to minus it because it's a lower number, right? So we get the negative number. Now if we get the negative number, so what I'll get minus 18. How can I get 82 out of it? Like, I'm just throwing straight away. How to get 82 out of it? What we can do? So this is what we have to figure out. Rest other thing is different, how we can generalize the this program, how we can get the median. Maybe we can take it as an array, then we have the length divided by 2, but how we can get 18? Okay, we can use mode and addition subtraction based on the direction of yes, addition subtraction based on the direction of rotation. That is good because it's already there in the problem statement. So we can use mode modulo. Yes, yes, absolutely, absolutely, good one. We can use modulo. So can you perform this thing? If we get minus 18, how we perform the modulo? If you have calculator around or something, how we can perform the modulo? So I'm just opening a calculator over here. So we have minus 80. Cool. see this, minus 80 percentile or modulo 100, we get 82. We are close. We are close to the answer. So what we'll do, so we will come with like we will come up with the general formula, right? So we will have minus 18 modulo 100, we get 82. Now this is the answer, right? 82. Now we will update the pointer position to 82. Very well, very well. This is good. This is good. But again, we have to figure out if percentage works on, like, behaves in Rust the same way it behaves in any other language. I'm not very sure, just thinking, because in our college C classes we used to encounter or ask question around this, how it behaves in other, why this is not coming like this but it comes like this in other thing. So but this is good thing. So you see, this is the thing, we have to keep this as a formula now. So we have, let's generalize this thing. If we encounter L, we have to do a minus, right? We have to do a minus. And if we encounter a negative value, then we have to perform modulo and update the pointer. Otherwise, if the number is not negative, then we will simply update the pointer. We don't have to do modulo. Why we are doing modulo? Because the dial, it says assume it as a circular. So if you see like a number system, imagine a number system like 0 to 99, right? So if I do modulo, the number I'll get is back again from the 99, like this. Can you see this? So imagine it as like this, there is 0, there is 99. If I get modulo on negative numbers, I'll reach somewhere here, right? So yeah, but let's figure out for R. Now we are at 82, the pointer is updated to 82. Now it says L30, again it's good, we are getting the positive number. 82 minus 30, we get 52. So the pointer now shifts to 52, right? Now we get the R value. So R value means towards a bigger number, so we'll do a plus, right? So it says R48. Now here is the thing, the pointer is at 52. The pointer is at 52, somewhere here. 52, the pointer is somewhere here. Now if I do R48, so if I pass 99, I'll reach again from to 0. So we have to check this thing as well. So what we can do, so we are at 52 and we have 48. I'm just thinking over here, right? So do we get 108? Oh, sorry. We'll get 100. We get 100. 100 means, ideally, technically, after 99, 100 means 0. So how we can get 0? Can we get 100 modulo 100 0? I don't know. Let's check. Yes, it's 0. So it means 100th value is 0, because after 99, it's a circular dial, it goes to 0. So we get 0. So for R, we will do this thing. Okay, what if R is a smaller value? So what if it's only a 4? Then we don't have to do anything, but we need to figure this out as well. Now the pointer at 0, so we get 0, right? So we will do x plus plus. It means the pointer stops at 0. It's not moving anywhere right now. The pointer stops at 0, so we'll keep track of this thing. We'll do x plus plus. Now again L5. L5. L5 means we'll have to go again towards left, so we'll have to subtract this thing. So 0 minus 5 will get a negative number 5. So if I do what did we do? Yeah, we did 5 modulo this thing. What do we get? Guys, come on, yeah. Minus 5, we get 95, right? It's a negative 5. We get 95. Does it have 95? Okay, 95. The pointer is updated to 95. I think we are close to create a formula, a general formula for L and R. So now we get R60. R60 means towards a bigger number. So we have 95. So let's imagine we have 95. We are somewhere here from the 99 and we get R. So we will move towards here. And what do we have? R60. So we are at 95. If I do R60, we will again come over here. The pointer stops somewhere here on the smaller value because due to circular dial, right? So R60, what we can do here? R60. I'm just doing it like this. I did, right? For R value, 95 plus 60. What do we get? 155, right? So again, if I do this thing, 155, 100. What do we get? We get 55. Is the answer 55? Okay, 55. So I think we are like, we kind of very close or just cracked this thing. So let's generalize this thing. For L, we simply do a negative minus. Sorry, we'll do a minus. For L, we will subtract the thing, we'll minus it. And here's the condition. If and only if the number is negative, we'll perform modulo. Otherwise we'll keep it that way. That x value is keep it that way. A, let's assume it A. And the pointer will get updated to A, or after the modulo we get A. So the pointer now shifts to A. So we'll have to keep track of a pointer variable. We'll just adjust the position to A so that we do the next calculation from the A's value, right? So yeah, towards A value, right? So we'll have something like, if we encounter L, then let's assume it input value IV. What I'm missing here is, how are you using this Excel pen so easily? So hard for me to do that. Okay, yes, mouse here. So I don't know if you are hearing those like click and the other sound that I'm like just striking my mouse on the table, but trust me, it's just like very thumping noise over here on my table. So click thumb, thud, like that. Amazing. We have 9 votes, and guys, make sure you show your presence by coming on chat, say hi. Let's make this thing very, let's make the session very engaging. All right, and we have 3 likes so far. Is there a setting in Excalibur you have to do? No, it's just a pure Excalibur. I just opened it right now. I just saw somewhere so it just I selected a pencil and just start scribbling. Okay. Yeah. So we have 9 votes so far. And guys, if you want something to be updated on the stream, make sure you come on chat. And if you hate the stream, there is an option. So don't forget to do that poll as well. And let me know what you hate about. And we have 3 likes for now. So let's shoot the likes to 10. Come on. So I hope you get this thing. If you have a pen with you or a paper with you, you can just create a simple formula and just type it on the chat. So we will denote input value with IV, because we have an input instruction that is going to run line by line. So line by line running means we can have it on a vector and we can loop it on that thing so that we get the each value one time. We can run a map on it. We can iterate on that list. So that's a secondary part. That's a coding part. But making a formula is a different thing over here. And make sure that if you encounter such kind of problems, so try to think it that way. Try to like think that way first. So the more you like kind of do these questions, the more your approach would be like that. It's okay if you like so let me tell you what happened is, when I try to solve like these things, I used to think it like programmatically first. I instantly say that okay, there is a set of instruction, I will have an array, then I will loop on that array. But the problem is something else. The coding part comes later, right? So as you can see on this as well, there is nothing like currently there is nothing coding part is there, right? There are few bits of coding, like we can save it on a variable, we can just increment that thing. So that's pretty basic, right? So yeah, if you encounter these questions, try to think it that way. Try to create a generalized formula over here and then use that formula and do that. Hello, happy new year, Andresh. Nice to see you again. Are you an undergraduate student or I have graduated way back? Give some non-typical advice for someone learning Spring Boot and backend engineering. Uh, like just try to build project as much as you can. I have no experience with Spring Boot, but with backend, yes. I kind of love backend. So, but I mean, this is the only thing, right? Try to build as many as project as you can. Try to like kind of rewrite everything, whatever you see or whatever tool you use. At least, I mean, try on that way. This is the only advice, general design, and like and true advice. Nothing else can really save us, but building project. Come on, guys, let's shoot the likes to 10. We need 6 more likes. Come on, you can do it. It's like a one thumb away. What was your stack and how did you come out of those boring REST APIs job? Uh, so my stack has been changed time to time, but I have been able to like fix it from past 3 years. I was working at starting. I was working as a .NET Core developer, right? C Sharp, jQuery, and all those back office projects. So and then when I switched job, I just forcefully moved to use front end, to use Rust. I hated it at first, but I learned JavaScript there. So then I use JavaScript, because if you know how to write console.log, you are a full stack developer eventually. So I use that superpower. I choose Node.js and then switched a company, worked there as a Node.js developer, and there I encountered some beautiful projects. So I learned a lot from there, and then yeah, full stack leap jump is not very far if you learn JavaScript and do a lot of projects. And then I got the time actually. So I was working from home and then I got the time to learn Rust, because I was very fond of using like C++ or something, but I picked Rust instead of C or C++. because I was like learning about blockchain technology. I was very moved by that. Then I learned about Solidity. I want to write smart contracts. So I was very confused between Solidity and Rust, like Solana or in Ethereum. So at that time, just to learn and for the ease of creating a smart contract, I choose Solidity. It, and because I just researched that Rust is very tough and all. After like 3-4 months I was building that thing, I figured out that okay, Rust has a much more vast ecosystem when it comes to development. It's going to be everywhere pretty soon, or it's there out, I don't know. So then I started learning Rust, and it's been a year. Then I started and implement, like, created projects. I created few of my Node.js services into that, and like migrated entire Node.js server from Node.js to Rust. Yep. So that was it. That's my stack now. It's JavaScript, again Node.js, React Native, TypeScript, React, and Rust. How about you? Tell me about yourself. Are you a student? Are you working somewhere? What's your tech stack? Come on, guys. 5 more likes. It's one thumb away. Make sure you opt for the polls. And if you didn't like anything about the stream, feel free to come on chat. It's open, very, very open chat. So, and also if you are like being on the stream from the very first, it's been an hour now. So I hope you don't have any questions right now, and I hope you were able to understand how do we approach the problem and how do we solve that. And yeah, now we have to just write a simple generalized formula for it, so that for each of the cases for L and R, we create a formula and then we put it on a program and then run, right? So tough part is over. I'm a fresher working in .NET Core at a startup, and at the same time, and in the same startup, I have worked in front-end developer in React. Awesome, awesome, awesome. Good, 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 good. Working on a startup will like help you a lot. Trust me, it will help you a lot. You will like see very, very, very different and very, very hardcore scenarios there, and you will have some strict timeline. I hope you will learn a lot, so it's a good thing. Yeah, you're on track, buddy. Nice, good going. Okay, so let's imagine the input instruction that will like denoted by the IV. So if we encounter L, we'll extract somehow the IV value. We'll figure it out how we can do that. And we have input value. And after that, what we'll do, we will have somewhere a pointer position as well. So I'll denote it by, let's say, PP, pointer position. So we have input value and pointer position. And if we encounter left, we'll define cases over here. If we encounter left, then what we will do is we will subtract pp minus iv, and we'll keep it into a variable called a for now, right? pp minus iv input value, pointer position minus input value will get a. Then we will figure out if the a is negative. Okay, so this case is there. Now we'll say if a is less than 0, what we'll do, we'll perform a modulo on negative a, because it's a 0, modulo this thing, we'll get a value b, and we will update the pointer position to b. So the pp is now b. So the pp started from 50, now the pp is b. And if a is not 0, or if a is greater than 0 or equivalent to 0, now here is the condition. Now if a is greater than 0, so here is a first case, here is a second case. If a is greater than 0, what we'll do, we'll simply say a is pp, a is pp. And it's a general case. Now if a equals 0 and there are no more steps or clicks away, there are no more steps or clicks to be performed, then there is a variable, we will have it somewhere like x, that denotes about how many like times 0 it is stopped on 0. We'll say x plus plus. So this one is for L. If we encounter L, this one is for L. Now let's perform the formula for R. So we will have some value like R40, let's say. So if we encounter R, then we have to perform something. This is the number of clicks. So we will have again a pointer position pp, input value, that is R40, and x, that is how many times it stopped on 0. So if we encounter 0, what we'll do, we'll have input value, because R is towards bigger number, so we'll do a pp. We'll have it on A, and we'll perform if the A is above 99, right? This is what we got. We'll go through the instruction again, because we just we only opted these instruction, right? We just left this. Maybe there is a different case there. So what we'll do, we'll do a plus, and so we didn't take the second case, right? So we have to go again on the instruction. So let's keep R somewhere. We have to go it again. So we have R14 here, right? So L50 is 0, we occur. So L55, the dial is rotated, it's 0. If the dial is rotated 1 towards left, it's at 99. Cool. If L0, if I do L99, it will again 99 minus 99, it's 0. Now let's say this. The dial is at 0. If I do R14, the pointer is at 14. So we are doing a simple plus. Okay. So R plus, right? What in this case? 52 plus 48. Just give me this thing. Let me just note this thing. 0, pointer at 0. So input value plus 0. So 0 plus 14. 100. Oh, we can always do a modulo here. It will not do anything. But will it? If I do, I encountered negative number, right? And then I again encountered negative number L. I'm just confirming one thing. So 82 minus 30 modulo. Okay, cool, amazing. So we don't have to actually check for negative numbers. We'll perform modulo anyway, because on the positive numbers it hardly does any effect. On the negative numbers it will do. So for the R, what we can do, we will simply add and do modulo anyway. So we'll do a modulo this thing, we'll get some value b, and we'll adjust the pp, the pointer position to it. And again, if we'll make cases, if a is equals 0, then we'll perform some x plus plus, and after everything is over, we will just do the output of x, and this will be our answer. Why I'm doing this thing, why I'm not checking it whether it's greater than 99 or not, because on the positive number it hardly affects. On the negative numbers we have to do that. So either we can do this as well over here. Instead of this like a condition, we can always omit this condition. We can always perform this thing. We can always perform this thing. So guys, does this make sense? These LNR thing, does it make sense? Come on, tell me. Come on. Well, I got 10 votes, so 70% of them, 7 people, are just amazing, amazing, cool, cool. So 7 people are a dev, and one is not. One is just visiting, and one just hated the stream. Cool. Okay, now the hard part is to write this in Rust. Now we'll take help of Google if we stuck somewhere. So I hope this makes sense. We have this dial, this log, and we have to just adjust the log. We are at the North Pole, it's getting cold, and we have to figure out this thing. And it turns out that the log is actually a decoy. The password is how many times the pointer stops at 0. So that will be the password. Okay, it was the problem 1 of advent of code. Secret entrance, day 1. All right, now let's perform this in Rust. We'll have it handy over here. LNR. Okay, L and R, these two values. Let me just shift this thing to here. Okay. All right. Advent of code AOC, day 1. So CD AOC, day 1. All right. We are here. Are you able to see it? Is it visible? Where is the chat? Okay. 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 Now we have to perform. We'll have a list somewhere, right? That list will have some instructions, and we have to split. Okay. And we need to figure out somehow that what is the operation. Is it L or an R? And then if you have your laptop with you, or if you are like, so you can perform that thing on your laptop, on your machine. All right, we have input value. So now we will just, first of all, we'll just raw write it. We'll just write it raw, and then we'll little by little add these things, right? So oops, we can have a folder here that says operations, and we have a file inside it that says mode.rs. And here I can say pub mode OPS. What the hell, this file is not included. Huh? Why didn't it create? Oh, okay. Arcade OPS node.rs. Right, so if I go inside this, I can simply, oh no, it just created a directory. So I'll just delete it. And here I can just create a file called mode.rs. That here I can call pub mode OPS. No such file or directory. And here I can create another file called ops.rs. Here I will have some function. So here I'll perform all my functions, right? And I will call it from main. And on the mode I'll just call OPS, right? And on main I'll just use this thing. Can't open file for writing. What the heck? What the heck is this thing? So I'll have all my functions over here. So what I can do is I can create a struct over here. I'll call it password generator, and what it should have. Can you guys just help me out here? So I'm creating a struct password generator. I need some things on it that I will call it from main. If you can just help me out design this thing. So this password generator will have functions. First of all, if I generate a new, I can pass in a list, right? So I can say input list, that is the document, right? And what it could be a vector of, right? It could be a vector. What else can we have it? We'll have input list that we can run on. So if I run perform new, then I can perform this thing. What else can we have it? What else? Think about it, guys. Come on, think. For now, let's say. Why does it saying the file is not available? I'll perform impl password generator. I'll just do we'll get the input list as a vector of string, right? It will return a self. Are you able to see it? You should not be seeing the full code, right? Let me just adjust the OBS settings. This. Maybe you can now. Come on, people. We need 5 more likes. And make sure you opt for the polls. And whoever subscribes, make sure you say hi on the chat. So yeah, let me just stretch the screen here so that it gets better. Let me check the OBS. This is my point Xcali draw. Is it also visible? OBS. Yes, I think this is good. I can write in this now. Okay. Where AOC? Advent of code. I don't understand this, buddy. Where AOC? All right. So it will return this thing, self, right? So it will do this thing and it will return the input list. Can't open file for writing. No such file or directory. src ops.rs. Yes, of course. What the heck is this? It says there is no such file. What does that mean? Let me just OCD1. Oh, we have OPS. We have mode and OPSRS. What the heck is this? Should I close it? Like force close it? Close ghostly. Let me open it again. Reopen, yeah. Mm. Okay. It's working now. Closing on it like this. Have you watched the IT crowd? There was this show called the IT crowd. So there was this guy that worked on IT, and whenever, like, in support, so whenever someone calls on their office, so it like later on it created a machine that has a predefined message. So whenever you pick it up, whenever they pick it up, so the machine automatically says, like, Have you tried turning it on and off again? That was a meme as well. So turning on and off again always works on everything. Yeah, bad job. Self. Yeah. So if you haven't watched that, I'll suggest you to like watch it. It is awesome. At first, I thought that it was made by someone who is like on LSD or something, but it's good, really good. I wish they have like some more episode, but it just like closes after 2 3 seasons, I think. 2 seasons or 3 seasons. And it was good, man. It was very good. Okay, so we have this function that returns this thing. Now, what else do we need? Our password generation, it will rotate, right? So what it does, uh, on the main file, I can initiate this password generator struct by passing in the list. Then it will return me something back, the input list. Then I can loop on that input list so that these operation get performed step by step. And on the main file, when I loop it, uh, on the main file when I do it, I'll send it here. So I can say perform rotations. So this is our function that will uh, it will get the instruction that will be of type string, and it will return. Should it return? Maybe we can have pub pp. We'll define it pp. Pp would be negative number. It could be negative, no. uh, and we will have password as u32. What else do we need? We need a pointer position that should be kind of this thing. We'll update it. We need a password that will return. And once the loop is over, I need a password, right? Input list, we have a pointer position, we have a password, and all those thing module and all that should be very scope based, right? It should be uh, scope of this function. So yeah, that is it. So we need a pp. Again, this pp has to be calculated. I know that on the problem statement it says it starts with 50. So we have two things: either we by default says that it starts with 50, or we can make it more kind of dynamic by calculating the length of input list and just getting the half of it. But for now, let's say we'll do oh, sorry, just say pp s50, and we have a password. For now, let's say 0, right? This is it. And here it should not perform anything. What the heck is this? Oh. Okay, so this function will only perform rotation. It will have an instruction. Now I'll say if uh, instruction dot, how do we check whether there is a specific substring present in the, maybe I can just make it a little font smaller. Yeah, so maybe one more. so that you can see it. Show me one more. Okay, yeah. So do you know there is a function contains? Cool. Contains a pattern now, and that pattern is L. Let's say if it contains L, now I need to extract the substring because I'll get the instruction as L60, L48 like that. Now I need that value, so I need to trim. So how can I extract uh, the value after the first character? Or maybe just remove the alphabets from a string, whatever is easier. We can check that out. How to extract a substring from a string. Trim prefix. Let's see. So sorry, we can do this. If we have a substring, we can say 0 to 5 m 0 1 2 3 4 5. So we get fifth element is exclusive, so we get hello. So we can say 0 dot dot 1, then we'll get okay, but we'll get L. So we can say 1 is included, right? So we'll say 1 to the length of list, but we don't know how much it is going to be. 1 to the length of string, we can say that. Let's check. Okay, so one thing okay. Okay. So one thing that I'm saying over here, that we are not like kind of improving the space-time complexity here, right? So we can declare as many variables as we want. It's a second thing to optimize this code. Okay, let me just, so we'll say let what do we call clicks equal to uh, mm, we can say, and instruction 1 dot dot instruction dot, do we have length? Can we do that? Can we just, we can't do that. Let me just print this thing. Clicks. I need to make this thing wider. Expected I32 found U size. Oh. Expected type found. Oh, okay. I have to just do this. Let me just put this screen back. So we need to figure out expected I32 get U size. U size what? This length. I need to extract this. Does this return? Okay, it returns a U size. So dot length returns a U size. One goes. Yes, that makes sense. That makes sense. That makes sense. Perfect. Amazing. We have clicks. Now let's shape this function. Awesome. Awesome. I will just do it again. So let's check what clicks do we get. So we'll call this thing in on our main file. We'll start this thing. We'll copy all those things from the statement uh, from the problem. Amazing, we have 14 votes. Guys, if you are joining, make sure you do uh, you like do your, please let me know your tech stack and feel free to come on chat. Let's work on this together. And also, if you just joined, make sure you like this stream, and to know what we are doing, just play it from the very first, maybe in 2x if you get the option, the playback speed. Or if you don't want to do that, let me just share the link what I'm doing. So this is what I'm doing right now. You can just check this link out. Okay, uh all right, this is pinned. So this is what we are doing. Cool. And make sure you like this stream as well. All right, let's hit it to 10 likes. Okay, let's go. So let's generate this thing. On the main, what we are going to do is we'll just say that p generator, no, that pass generator is should be password generator new. Now we need a list over here, so I'll say let input list equals it's a of string, right? So let's copy these things. Maybe we should just do this. right? And I need comma. Maybe I can just search it. Mhm. Mhm. Yes, I can just replace it with no, 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 no. We'll have this. No. What is the regular expression for if I want to just check out the numbers? Any idea? Anyways यार इतनी देर में तो okay, now this will go over here. Input list. This will throw an error though. This will throw an error because the expected thing is different. Right? Uh, I get the input list and this thing would be this. Missing lifetime. Guys, how to solve this thing here? If I do a string slice over here, it is asking me for what is this? Named lifetime parameter. Infected with lifetimes, yes. Yes. Um, hmm. Hmm. Yes, I'm checking one thing. It says cannot be known at compile time. Of course. The struct holding this field must include a lifetime parameter like this. Where scope the string defined by this must be valid for an entire lifetime. If the data goes out of scope, the reference become invalid, leading to a compile time error. So I need to define this and then this. Person is valid only as long as name is in the scope. To avoid this in struct, if a struct needs to own the data to store it long time or pass it across function boundaries, yes, we have to do that. Use a string instead. We did that, but I have to keep like do that. Use cow for functional like flexibility. You can put a string, it doesn't have to be str just because it's a struct, yes. In fact, it's more advisable to prefer owning types over borrowed types while you are learning the language. While you are learning the language. String. Yeah. Hey, see what it says. You can put a string inside a struct. It doesn't have to be this slice just because it's in a struct. In fact, it's often more advisable to prefer owning types over borrowed types while you are learning the language. Needs a lifetime because it's borrowed reference type, and it when it's a part of another type, the compiler needs some annotation on how long do you want the referred to string slice to live at least. That is, a struct may be constructed, used, and destroyed in any number of ways, and the compiler can't infer the underlying lifetime based on the type definition alone. In contrast, when you actually use a this thing in executable code, it will be inferred more often than not. Of course, this is all we had. You know what? Let's try to do this. Let's see what we'll encounter. Is this what it says? Constant provided when type was expected. Expected a comma. Oh my god. I just don't want to type over there. Maybe I can just use toString. Uh, Only one. Why it's only one? Mm, and then a comma as well. Map an str to string and then collect to a vector. Okay, so you are saying that this thing on this vector, I'll just and collect to a vector. Yeah, that could be done. To owned is clearer, but to string works too. Hmm. Okay, now let's see. Uh, yeah, we can optimize it maybe later, but let first do this. So I need to print the clicks, right? So I can say gen dot. Oh man, this has to be done like this. Home rotations. Now here I need to pass in the instruction. So ideally what we do, we can just iterate on input list, but for now let's say I can just pass L68. Mm, okay, let's run this thing. We should be getting 68, 68. Okay, okay. Just give me a minute, guys. I'm getting a call. Till then, you can figure out anything. I mean, what the problem is and how we can solve it. Check for the link that I have pinned what we are doing and keep yourself engaged till then. Hello, hello, hello. Yes, come on. We have 16 votes. Guys, who is watching, just make yourself Comfortable here? Come on, chat. We have 6 like. We need 4 more to go. And I have also pinned the link that we are working on currently. And if you just scroll up, you can see my GitHub, my Twitter, and buy me a coffee link. So just feel free to follow me on GitHub as well. Check out, I have some Git repository there. So if you are a beginner in Rust, then you can contribute too. I need to put on a charger here. Just give me a while. So we have this. So guys, if you are on this stream from the beginning, I hope you understand the problem and the solution that we have figured out. Now it's the main problem is to write that thing into a code that you can do if you have some other language, whatever language of your choice. The solution is simple and you can always do that. Let me put my GitHub link again. So this one is for GitHub. This one is for X or Twitter. And this one is another link for the thing that I created because everyone else was doing that, so I thought I should be creating one too. Damn, aren't we live? Why does it shows? Okay, cool. Guys, come on, 3 more likes. And feel free to come on chat. We have 18 views, votes. Come on, let's make this likes up to 10. And we can now come over here. So I got the clicks now, right? So these clicks that I have to perform, right? Let's make another case of else if we encounter R. So this one is if we encounter L. So remember, L is towards a lower number and R is towards a bigger number. So imagining a scenario, if we have a circular dial that is pointing to 50, then rotating towards L will do 49 these things, right? 49, 48, 47, 46, like that. And rotating to R, it will just increment the numbers, right? 51, 52, 53. And one thing to note over here is as we pass 0, it should reach 99. So to do that, we will use a modulo operator, because in the number system, negative number is basically, if you perform modulo, then it will be from 99, like towards from the back, right? So these are the set of instruction. We need to figure out how many times did the pointer actually stops at 0, right? But we need to make sure that whether this modulo works on Rust like we expected or not. Otherwise, we'll have to take help from Google that how we can wrap it. I I think it is wrapped by doing like adding 100 to it and then again performing a modulo. like this, some x value, some negative x value plus whatever we have over here, right? Plus 100, then again wrap it to 100, right? So we can do that. uh, yeah, this one is for our, so okay, so we have the clicks now. Let's quickly do that thing, otherwise the stream will all be about like being fuzzy over here. So there are 2 hours already passed. So we have the clicks, now we have to rotate it. Okay, so let's come out on the formula that we have derived for L and R. So this one we have derived for L and R. So if we go towards L, that means we are going towards a descending number. So what we'll do, we will have a pointer position over here, right? So as you can see, we have a pointer position that we have defined it with pp. So we will subtract input value, the number of clicks that we will receive, we will subtract it from here. And so the clicks is basically a string. Now how we can get it like to be parsed? Anyone, how we can do that? Can we do this parse? Oh my god, u32. So the clicks is now integer, unsigned integer. Electricity gone, guys. Let's hope that it came like come back. Don't worry, but I'll switch it on to my Mac if I just remove the monitor, right? The problem is it's charging as well, so maybe removing the charging will give us some couple of minutes. So we have this thing now. We got the clicks, right? So let's go on the first thing. So if we receive any input, we receive this thing and we have this thing, right? The pp is the pointer position, x is the password that we have to keep on incrementing if we stopped at 0. Now let's do the first step. pp minus iv, pp minus iv will get some value over here. So I'll say let a equals the pointer position, that is pp minus clicks. This is what we have to perform. Self, right? Now here's the thing, modulo operator on the positive values it won't affect anything, but on the negative values we will get the value from the other side of 99, because the dial is circular. And what modulo does is, in a number system from 0 to 99, so if there is a negative number and we perform modulo, then it's the number from the back from the 99, right? So we already discussed about this, right? So if let's say if we have a pointer position at 50, let me just do it over here. So let's say if we have a pointer position at 50 and we have to perform L68, then this means pp minus clicks is the 68, right? We'll get negative 18, and when we perform negative 18 modulo 100, we'll get 82. So this is how we replicate this circular dial, right? Negative 18 modulo 100, we get 82. Now let's see, we have to do this thing only, right? And so we'll say let b equals a modulo 100, and what we'll do is we'll say the updated pp would be self. So again, if we are mutating this thing, so we'll have to have this thing, right? So now we'll do self dot pp equals b. Now the pointer position is updated. Cannot subtract result. Okay, u32 from this. Self dot pp is the result, right? So maybe we can just parse returns a result. Okay, so we are going to do most unsafe thing here. Ideally we should do a if let statement, right? What returns cannot move out of clicks behind the shared reference. Oh, okay. So this is not the way. We'll have to do some if let statement if we have any inlay hints, please. Okay, so yeah, so we have click dot unwrap over here. And now the pointer position is updated, right? This is what we do. Pointer position is updated. So if this is greater than 0, again we have defined some condition over here, but it turns out that on the positive value won't do any effect, so we will somehow only do this. So we have updated the pointer position. Now q is pp, okay, a is pp, okay, that is good. Now the pointer position is updated, b is pp. Now we have to figure out one thing, whether it's an L or R. Can we do that? Okay, now we'll say if a equals 0, then what we'll do, we'll do self dot password plus plus, or maybe plus equals 1, right? If the pointer stops at 0, that means we have to increment the counter, and finally we have to like return the counter if we want to find out the password. Now let's come on R side. If we get an R, then again we have to figure out the clicks. So it turns out that clicks will be used anyways, right? So we can just move it at the top. What do you think? Right? So we need the click. On the R, what we'll do, because R is a positive value, greater value, bigger number, towards bigger number, right? On the circular dial. So what we'll do, input value plus this thing. Okay, so we have clicks. So what we'll do, we'll create another thing over here. We'll say let a equals self dot pp. Now the pp pointer is updated, right? So we will do input value plus, come on, clicks. I have to like do this thing before my UPS dies. And then what we'll do, we'll say let b equals a percentile 100. We'll optimize this thing later, right? So we are just like doing a raw coding over here. So again, if so, it turns out there is only one thing that should be out, that is this. So maybe instead of, anyways, let's do this thing first. So the only condition that should be over here is this, finding out a, right? Because a rest of the thing is quite similar on each of the thing. So we have all these things, and when this all is like, when this all performs, and we need another method over here, public function get password should return self dot password, because, oh, did I just make a fat arrow over here? What I'm thinking, it JavaScript. Okay, now this thing, uh So this goes well for each of the thing, right? Maybe I can say value assigned to A is never read. Never read. Maybe it's written being before read. Let's figure out. So A will do this based on L, otherwise this. Then we will have this A over here, and then we can simply say if A is 0, we'll update the password to this, right? And at final we'll do this. So now what is the issue in this? Cannot borrow as a mutable, as it is declared as mutable. Cannot borrow password gen as mutable. What the heck? Okay. So this thing, we need to perform iteration on the list over here. Oh my god, UPS is dying. UPS is dying. Let me remove this thing. And let me remove the keyboard as well. Will come directly with laptop this time. So maybe use this mouse. Now I need to adjust OBS. Okay, so you have to bear me. Or maybe I can just pass it here. Okay, and if I do this, screen capture 2 is this screen capture. I have to update this. Display capture, not, it would be display capture built in retina. Yes, this is good. Let me just stretch it out here and maybe do this. Is it visible? Maybe I should not check it. Close this window. Right. Okay, you should see code. Main thing is that. Okay, so are you able to, let me just close this browser as well. Close all. Are you able to see this thing, right? All right. So on this window, let me just add. All right, I can see some chats over here. Yeah, so now let's iterate on this list, and you can just do this, right? So I'll say input list dot uh, into iter dot map. Mhm. Now here I can say password generator dot perform rotation, and I'll pass just item. Use of moved value input list. So input list is basically moved on the new, right? So smashed type. Now I hope this is not lifetime parameter. Damn. So guys, this input list is moved here. Now I cannot use input list over here on the password gen. So. Maybe I can just create a cloned input list and then just run it over, right? Clone input list. What I can do, let cloned input list equals input list dot clone. Borrow. Let's keep it on top. What is this thing? Lazy and do nothing unless consumed. Unused map that must be used. Iterators are lazy and do not and do nothing unless. Okay, so once this is done, what I'll do, I'll just say pass gen dot get password. Hmm, expected this found you 32. Okay, and I'll just say this thing, password of the no password is. All right, there are very problems with this code, but again, that is this thing we can always do. Let this to ignore the result. Of course, of course, of course. So input list never read. Mm, input list is never read. What do you think? Is there anything, any problem with the list or something? Or do we see the output like expected? We need 3. So we have taken the sample thing, sample input that has been provided in the document. Advent of code. Right. So this is the sample doc that we are using, L68, L30, L48, like that. And yeah, so we should, the expected output should be 3. Okay, now let's see, do we get 3 or not? Let's run this thing. Password is 0. I know why it is coming, because we are just using self dot password. Why is it? It should be updated. Okay, no. Is it due to the cloned input that we are passing? It performs rotation based on the item and the instruction that I just pass. It should update this thing. Maybe we can just say, let's try this thing. After doing everything, we'll just return self dot password. Let's do not touch this thing for now. Mm. I think this is going to be very bad. I don't think we have used this thing, so maybe we can use just for loop. Because after each uh, operation it should not return, otherwise it should not return after everything. So this is quite a wrong approach. This should be the correct one. Get password is never used. And maybe you know what we can do? We can say input list is already moved, right? So we can say input list for item in input list. And dot get password. Hmm. Error. Error in. Hmm. You have to compare self dot pp equals 0. Did I do anything wrong? Let's see. Self dot pp. No, 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 no. See, before. Oh, yes. Oh, yes, buddy. Okay, ideally, this should be the last one. I just moved, but this should not be the case. This should not be the case. I get A and then I do B, and after doing everything I should check for B basically. Yes. Yes, with my previous approach, yes, self dot pp equals 0, but it should, the assignment should be in last. Only if it is yeah, correct. You are correct. Good one. Okay. So maybe let's see if we get 3. 0, still 0. Still 0. We already did that. Self dot pp equals 0. Now we have to debug this thing. I think there is a issue with. I don't think this would be an issue, right? Cloned input list. Why would that be an issue? Because the list is same, so I think we can do it, like clone it. I mean, I know this is like, but if I pass in the input list, I should get the password gen. So because it shouldn't be anything, this should not be an issue, or it should be. Mute a. So a equals this, and b equals this. I think the issue is with modulo. That's what I said it in earlier. Like it behaves different on different languages. So why don't we check B over here? Println. Uh, then we have to wrap it doing some crazy things. We have to check out. So let's see. Mm, cargo run. It's a warning. The password is 0. It didn't even print B. Why the heck is that? Uh, just one thing. Maybe, Mm, let's not go anything. Let's not do anything. The password is 0. It should print 3, at least a B value, but it's not. You need dot map doesn't run. Oh, you need dot for each. That's why I wrote like for this part, right? Maybe this would work. Where is. Now I get the error. Attempt to subtract with overflow. Mm. Let me just check one thing. Modulo calculations in Rust. 0 because of the so Rust perform integer division. So the correct percentage convert at least one operand to a floating. Okay, for more advanced modular arithmetic. It says it takes the sign of the first one. So if I do minus 18 modulo 100, so the answer would be minus in negative, but it should be 82. if I'm not wrong. This is what it says. uh Wrapping modulo. -7. Unlike this, it should get 2. See, this is the issue I'm getting. uh so basically modulo, they are like kind of two. There are two kind of things, so we have to do Euclidean modulo. Like the other programming languages, they just works perfectly well, like Python. If I do -18 modulo 100, Python will return 82, but Rust will return something else. To check that, uh, and again I'll use for each, so over here, but let's see. It's not about the error right now. Let me just let me show you one thing. So if I do print ln -18 modulo 100, so I get -18. I should get 82, right? Because in Rust it takes the negative sign of the first integer. So if I'm doing -a modulo b, so the answer would be the negative. It takes the sign of the first integer, the first value a. So this has to be changed. -18, I should be getting 82. So I need to wrap it somehow. So there is a function in this dot rem Euclid, but there is another way. There should be another way. Maybe I can get in this thing. There is another way with this. I mean, we should not be worried about this, because if we are having the function dot rem Euclid, then we can do no issues. So dot rem Euclid RHS. What is this? Ram Euclid. Oh, 3 3. Okay, Ram Euclid is this, and I should do -18 dot Ram Euclid. So I should get now 82. What the heck is this? Numeric type integer. So let me just say let answer equals -18. Okay, -18 dot Ram Euclid 100 unambiguous numeric type. Why? Custom wrapping with modulo crate. The modulo crate provides a fuller modular arithmetic system. Maybe I can just, I have heard it, like read it somewhere. Plus 100 modulo 100 again. So I'll say like this, a something like this. I'm not very sure. It if it's like that or not. In Rust, to compute this with proper wrapping behavior, you can use RAM Euclid. What is this? Okay, unsigned के लिए तो ठीक है, it will work. But for negative, we have to deal with these language specific things. In Python, this is the modulo operator which always has the same sign as the right operand. In Rust, this is the reminder operand which gives a negative result if the left operand is negative, like this, right? Minus a percentile b, the answer would be minus sign of the left hand one. There should be something. If this is this. A dot ram Euclid b. So a is an integer, that is a negative one, and if I perform a ram Euclid on b, a ram Euclid on b, low battery, no electricity, low battery, low electricity, needs explicit types. You need for each w needs explicit types. Buddy, let me just show you the problem that I'm facing. I'm not only facing like this thing, but also I'm dealing with the low battery. You see, it's 10%. Electricity is not here. UPS will die. It's already dead. That's why I removed it. So we can figure this out, I mean, later, but I thought is a negative integer, let's say this, right? And if I perform a dot ram Euclid, okay, so the answer should be, now let's see what happens, right? Answer, I should get 82 because earlier I was getting minus 18. Okay, so this ram Euclid, we have to perform it on the different file. See, 82. This is what we need. We were getting minus 18. That is not very correct, right? If this were Python, then it should be like doing this thing. So we need a ram Euclid method. Now we have it available in Rust, so we can do that. So instead of doing this, we need to do a dot ram Euclid, and RHS would be this, and I should be doing it over here as well, because now it's a positive value r, it shouldn't be like that. This should work, but just to be safe, now let's see the other issues that we are facing. Attempt to subtract with overflow on 18th, this thing over here, click start unwrap. Why is that overflow? PP is 50, right? So 50 minus clicks dot unwrap. Oh, zero. Okay, the last part is exclusive. Is this correct? Like, shouldn't I write zero? Zero is inclusive. Okay, so I have to write one. I just need to pp and clicks. Self.pp and clicks. Well, you moved. Okay, let's check this only first, because we already have checked it, right? It was coming 68. Let's check this thing first. Okay, I'm getting 50 and just to check, this thing, let me just do 68. Guys, why is this like kind of should be I32 found U32 and B would be I32. Of course, it should not be negative. This is it. Attempt to subtract with overflow. In most oh, Expected you 64, found you 32. Attempt to subtract with overflow. Is it due to that, like, I'm returning a, like, doing something like this, 0 minus 1 or something like that? Hmm? Because I'm doing 50 minus 68. Prints 5. idx dot wrapping sub 1. So if I do 0 minus 1, guys, where are you? We have some serious trouble here. We have some serious trouble here. Whether we are about to die. And this is very embarrassing. 3%. So I'll have to quit this thing, but again we will restart from here and think how this thing is going. So it says attempt to subtract from overflow. So is this due to, like, the pointer position is at 50 and clicks dot unwrap is 68? Just before dying out, I want to search one thing. What will be 50 minus 68? What is this? Is it just referencing to Rust game? Using unsigned will result in an underflow. Oh, using unsigned. Oh, damn. Oh, ho, 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 ho. Low battery 2%. Guys, I just find out. We should not, of course, be using unsigned. Damn it. Damn it. Because how can this be unsigned? Idiot. This has to be a negative value. It should be I. This was freaking. U64. I should, like, convert the 64 to 32, but it's okay. Hey, password is 3. Yes. Did it. Did it. 0 comes 0, 1, 2, 3. So the password is 3. Amazing. Awesome. Freaking awesome. Let's remove these things. Amazing. finally, when the laptop is about to die, we were able to solve this thing. uh, oh, shit, you haven't been able to see this? Oh mother, sorry. I just, yeah, so see what happened. I just used these values as unsigned, right? But the thing is, there could be a negative value here on A, right? And I was using U64. I was expecting it, like forcing it to be U unsigned, positive value. But it could be a negative value as well, right? And for that negative value, we have to calculate RAM Euclid to get the value from the back of, if I use modulo 100, I'll get in a number system, I'll get the value from the 100 back to from the back of the 100, like 99, 98 and all, right? So yes, that was the issue. That's why we were getting overflow error, and the battery is about to die. It's 1%. Let me just show you. But the good thing is we were able to figure out why the issue was there. And shout out to all the guys. Indresh, thank you for being active on chat. I really appreciate it. So yeah, this part is done. Maybe I can just push it on GitHub later on so that you guys can check that out, maybe improve it, optimize it. All right guys, thank you very much. I'll see you next time. Thank you very much. Thank you, thank you. The battery is about to die. Okay, bye bye. I hope you like this stream. We have 7 likes, so uh make sure you like this stream as well. All right, we need 3 more likes to get 10 likes. Cool. It feels good to solve this. Okay guys, I'm ending this stream now. Thank you very much. I'll see you next time.